Hello. In this video I'm going to show you how to create a graph visualization application from your Neo4j database using the yFiles app generator, which is a free tool available from our website on www.yworks.com/app-generator. If you open that application, it will greet you with this welcome screen where there's actually a video that you can watch to see a short introduction that is non-specific to Neo4j. In this video, it's going to be all about Neo4j. There's actually an example inside the sample project that works with Neo4j. There's even more examples, and I'm going to start with a simpler one first to get this explained in detail. Okay, so this is a pretty minimal setup that I have right here. If you want to create your own setup, you can start from scratch or start with one of the existing ones. You use the node palette on the side to create nodes for the flow. In this case, I will be using the existing one over here because it already has the database details filled in. You will have to insert them specifically for your database. If it's on localhost or hosted via secure sockets, you can directly connect to it if you visit the page via HTTPS. You can also remove the S and visit this page via HTTP if you don't have a secure connection to your database, because otherwise the connection will not work. You might want to use a local proxy on localhost if you don't have a secure connection to your database, but still are running it on an external server. Anyway, this is a limitation of the web platform where an HTTPS page may not connect to an unsecured connection. So you will find this in the documentation of the various web resources. So for now, I'm assuming that you can connect to your database. Otherwise, you will get an error, just like, let's take another one. So now you get to see that there's a problem with the connection because, well, obviously there's a typo in it. But once I have this Neo4j loader added to my flow graph, I have specified a query. In this case, it's a simple person-directed movie query because I'm actually connecting to the movie samples database in Neo4j. It will use the Bolt protocol to issue the Cypher query and send that query to the server. The server will then get back with the results, hopefully, and this node at runtime will automatically split up the results into sets of nodes and sets of relations. You also get the raw results in this data pin below here, but we'll get to that later on. Ultimately, we want to create a graph visualization like over here. So this is not the graph that your end users are going to see. This is just the graph that describes how our application will work and extract the data from the Neo4j database, load it into a graph, and then visualize it with a potential transformation step in between that we'll be using later on. So this is the graph that you will see in your application. If you hit the play button, you see how the application could look like once it runs. So this is not at all useful yet. This is because we have been using the default settings, but let's see how that works. In order to actually build a graph, we're using this graph builder node from this section over here. The graph builder node basically takes one or more sources of data which will be interpreted as either as nodes or as edges. So the little plus sign over here means that I can connect multiple node sources. So later on, when I create a node source, I can just connect a second one, and that will also be used to populate the graph. But in order to get something useful, you should probably at least connect one node source. Without an edge source, obviously you get the nodes but no edges. But how does it work now? the values that we get back from the Neo4j loader are the properties, are pretty much exactly the same properties that you get from the raw Cypher bolt protocol, meaning that there's all the properties of the nodes. In this case, it's strings, but also numbers, which are stored this way in Neo4j with a high and low integer. And it could also be arrays and nested and so on. And of course, there's labels which depict the type of node and the identity that we can use to reference the element in queries. As a convenience, we also made this ID shortcut. So if you get your nodes from this one, there will be this artificially created ID property, because the identity property is so, well, slightly complicated to deal with. You will see why that in the next step. Because in order to create the nodes and then create the edges, we need to understand how the edges relate to the nodes. And for this, the Neo4j database will return to us the start and end property, which are both IDs, which resolve to nodes in our graph. And if we get both edges and nodes back from our result, we want them to connect. We want those edges to connect those nodes. This works by telling the edge source over here in the configuration panel which properties to use to identify the nodes. So I'm using start ID and end ID as an expression that will be evaluated against the objects that we have in here. So this is start ID and end ID to determine where the node or how the node can be identified. And if we look at the nodes, they have this ID, and we also specified that ID is the one to watch out for. So Graph Builder goes, iterates over all of the nodes, creates the nodes in here, then iterates over all the edges, tries to resolve the nodes, and then creates the edges in between them. So that's the default setup. You take all the nodes, make them nodes, and you take all the relations, make edges out of them, and then you get a diagram. Typically, you won't have any coordinates specified in your data source, but so your graph will be, all the nodes will be on a default location, which is at the origin of the canvas. So what I've done here is I added an automatic layout node in between that will arrange our graph to at least non-overlapping. So that's not terribly useful yet. We'll see how we can improve we can improve the situation later. Okay, but first, even though this is the most basic or almost the most basic setup, we're going to add some labels in here because this is pretty useless so far. I have, in this example, I have prepared 2 sets of nodes and edge creators. Let's just rearrange this. So each node source or edge source can have one node or edge creator respectively associated with it. And this configuration node determines how the node or edge looks like. So here I can determine the style I want to use. In this case, I want to see different shapes. I can specify the colors for the fill or the stroke or the shape. And also I can specify location and size, as well as some additional properties that I'm not going into detail right now. And this can be either hard-coded values, like in this case. Let's make this like 5 pixels red. You see in the preview already, they got this thick stroke over here. And but this could also be data bound. So instead of using a constant over here, I could also add an expression in here that uses the data to derive the values from. For example, I could be using the information about the title and convert that into, well, for example, the color, the thickness, or the fill, and so on. let's just try it. Let's see. We have this released date over here, which is a number, or can be cast to a number, and we can try and use that value to influence the stroke thickness. So instead of using a constant over here, we're going to try to use an expression. So we're going to convert the following into a number, because this is actually a Neo4j property. That's not a number, but it can be interpreted as a number. So we're going to use the released date. Let's just make it bigger. Number released, and let's divide that by, let's say 100 or maybe 300. And so now this is the release date, and divide by 300. And this is just the stroke thickness. So let's make this a string. That's the number of pixels, and it should be red. Oops. So this is JavaScript template literal syntax. I hope this works over here. And now we get to see different stroke. Well, they're pretty much the same thickness, because they're all released in almost the same decade. But yeah, you know what I mean. The same for the labels, where in this case I'm showing the type of the relationship. So type is an obvious choice. I can add any number of labels to nodes or edges, as you can see by the plus sign. So I could add multiple labels showing different properties, and that works by just adding another label configuration to the edge creator, and maybe specifying a different placement for the labels. Let's try a hard-coded text, just like text, and then we see directed and text over here, and this could be like, let's make it also white. And now we have text over here and directed over there. And if we change this to use the acted in property, this should give us a different result. And the beauty of this is that I know that the relationships in this case actually have properties too. So we see the roles. So instead of rendering just the static text, we're going to use properties.roles. And this should give us Carrie and Moss acted in the matrix reloaded as the role Trinity. So much for the basic setup. You use label configurations and edge creators and node creators to determine how the elements should look like. And you use the node source and edge source in the graph builder to determine the structure of the graph. The layout node determines how the elements should be arranged in the resulting application. But let's see what else we can do. Sometimes, oftentimes actually, the schema of the data is much more complex, but often we also have information inside the nodes and relations hidden as properties that we might also want to visualize as nodes in our resulting diagram. And we can do this without actually changing the schema of our database, meaning that even if there aren't a certain type of nodes in our database, we could render certain properties, for example, as nodes, or even additional data that we get from additional data sources. So let's see how that works. As we've seen before, the nodes, some of them are actually movies, and whenever they are movies, they have this release date. And what I did here is that I first took all of the node results of this query, because in this query we have persons and movies. And I'm using a filter node, telling it to filter for the first label being a movie. So this means out of the 13 query results, only 7 will remain, and these are all movie nodes. They have different properties, of course, and they have different release dates. So that's the release date when the movie was released. What I now want to do is I want to create a node for each decade. A decade a node has been released in. So like it's a 1990s movie or movies of the 1980s and so on. So in order to simplify that task, what I first do is I use this set node over here. It will iterate over all the values and evaluate a function and add a new property to the values. In this case, the property name is decade. And you will see that I'm adding a new property to this data object over here. So this happens on the client. It doesn't happen in the database. We're only using read-only access to the database. And how do we do that? I used a little function over here. So I'm using the release date divided by 10, floored it, and then multiplied by 10. So that this gives me the decade. So we have 1990s, 2000s, and maybe 1980s over there. So different ones, but there are duplicates in there. So what I do next is I pipe this through a distinct node and tell it to use the decade property to find unique elements. So this one filters out duplicates. And in the end, we're left with 3 different data sets for the 1990s, 80s, and 2000s. And now, for those 3 elements, we pipe them into another node source. So this is the regular node source, which creates all the graph over here. But I have this second set of nodes, which now should produce 3 different nodes. And I'm telling it to use the decade as an ID for the node. Because I know that the prefix decade doesn't exist in the Neo4j database. So that's unique. And I'm actually specifying a size and colors for this, and printing the decade plus the letter S appended as a text on the node. Let's see how that looks like if I connect this to the graph builder. Watch the result graph. Now I see the 1980s and 2000s added to the diagram. And now that's not useful yet because we lost the relationship between the movies and the decades. So what I would like to do first is create an edge between those movies which were released in the 1990s and the 1990 nodes, and the same for the other nodes, of course. So for this I need to have one edge for each movie. So I'm just reusing the filtered set of movies with the decades added to it, and this time I'm piping it into an edge source. So that's a separate edge source, meaning this will create edges, and the edge will point from the ID, which is the original movie, the ID of the original movie, to the ID of the node which starts with decade and uses the decade value, meaning this references the decade to each corresponding movie node. And when I do that, I get to see the expected results, and all the movies are now connected to their decade nodes. Cool. But it's not always a good idea to add more edges to a diagram, because it might clutter the visualization. If you get too many edges in your diagram, it might get pretty confusing pretty quick. So there's a different option that we have here. Again, I'm starting with the decade node. So that's the same pipeline that we had just before. So this adds the decade nodes over here. There's nothing different. But this time, instead of using the nodes to also create edges between the movies and the nodes, I will use a feature that allows me to nest nodes in the visualization, meaning that some nodes can contain other nodes. And this works by specifying a function for each node, telling which other node is the parent to nest the node in. So we can use any nesting level, but in this case I just want to use a very simple function where I'm only looking at the movie nodes, and because for all other nodes, I don't want them to be parented with within another node, so I'm just returning null for all other nodes. And whenever it's a movie node, I'm just recreating the ID for the corresponding decade node using the same calculation I did before. So we're simply creating like decade 1990 as an ID. And for each node this happens, and then once I apply this, the nodes will be placed into these compound group nodes, and the automatic layout will come up with this nice sequencing so that they will be placed next to each other. Okay, this allows me to depict this relationship without adding more edges. But sometimes I want to see additional edges, like edges that maybe aren't even in the database. One such example is transitive relationships. So the database, the movie database, has all these persons who acted in movies. And of course, sometimes there's a movie where there's one person who acted in that movie and another person also acted in that movie. So this query over here fetches pairs of persons who were co-acting in the same movie. And with this where clause, I'm making sure that I don't get any duplicates and in my triples, because this basically returns a triple for all the actors, for in this case 30 actors or pairs of actors which co-acted in the same movie. So A1 and A2 are actors and M is a movie. Now, in this case, I'm using the raw data because I don't, technically these are all nodes. If you look here, this will result in 18 different nodes in the movies and persons intermixed. But now I want to see a graph where I only get to see the actors, and they should be connected by an edge whenever they co-acted in the same movie. So what I'm doing here is, first I want to get my actors out of this. So I'm using the projection node to select A1 and A2, which is part of the data for each of the data sets, the first and second actor. And there could be duplicates in there, so I'm making sure that they are distinct by looking at the identity property and piping this into a node source. So this is 13 nodes, and here they are. These are the 13 nodes. And now what I'm doing is I'm also again iterating over all the 30 data sets and piping each of them through an edge source. And this time I'm telling it that I want to create an edge between actors A1 and A2 for each of the results. So in order to do this, I need to use the identity property of A1 and A2 and use them to identify the nodes in the node creator. Now, this curious toString over here is due to the way that Neo4j stores its identity. Identity is actually an object, and objects and equality, and they aren't equal. So understanding that they are the same is a bit difficult. So what we're doing is a legal little hack that is we are executing toString on these objects, and they actually create the string representation of this number. And strings are easy to compare and quick to look up. So whenever we don't use the nodes and relationships from up here, we, in the case of using identities for IDs, it's a good idea to toString them. So in order to reference to the first identity, I'm using A1 identity.toString, and the same for A2. And for the nodes that I already created, I used identity.toString just the same, so that they match up. There's still this get function. That's an oversight that should be removed. this doesn't have any influence on the results. Now that I have these edges and I explained to you why you should be using the toString, let's see what happens when I add this to the graph builder. And this actually adds edges between the different actors. And specifically, we're using the M property over here and its title property to add the name of the movie, the title of the movie, to each edge. This works by specifying an edge creator, where I chose to not show any source and target arrows because these are actually undirected relationships conceptually. And I specified a label configuration which uses the title of the properties of M, the movie, and a gray color. And if I run this, these are the results. So these are, there's Cuba Gooding Jr. co-acting with James Marshall in A Few Good Men. And for example, in the case of the Matrix trilogy, there's you can see that Keanu Reeves and Carrie-Anne Moss co-acted in all three of those movies. So much about extracting and transforming the data. Now about visualizing it, about changing the way they are rendered in the visualization, because there's so much more information in the database than just the structure of the graph. There's also these properties. We've seen the title already, and we've used the release date. But it would also be cool to, for example, show the tagline right in the visualization without the user having to like click on the node and see that in some detail pane. And we also have things like the birth date of the actors in there, and there's votes for movies, and I think it would be really helpful, depending on the use case of course, to see that right in the visualization rather than just seeing some boxes maybe with some labels. So what I did first this year is I split up my results, which returns both movies and persons in the same, and I'm passing them through to filter functions so that we get the movies and the persons in separate functions. Each of them gets their own node source. So this node source only creates the movie nodes, and this one only creates the person nodes. This allows me to specify two different node creator configurations. And with two different node creator configurations, I can, let me show you that. I can specify a different color for different types of nodes, for example. But color is not enough in this case. So I asked our designer to come up with a template for visualization for movies and for persons. And I told them what properties they should consider. And they used a tool like Adobe Illustrator to design a simple SVG template. So if you design your a vector graphics with Adobe Illustrator, you can export that to SVG, and yFiles can deal with that, can use that SVG, and you can enrich it with some template binding functionality. In this case, I'm using Vue.js templates, but you can actually also use React templates or something else, anything else that works for you. And in this demo, Vue.js is the one that we have added by default. So I took the SVG, pasted it in here, and then removed some of the hard-coded values, like the name, which already was in the design template. And instead of using hard-coded values, I'm now referencing the values from the database that the database returns to me. And for example, I'm using the name property here, and I'm also displaying the born, the birth date with this star in front of it. And you can see that there's some conditional rendering over here that checks for the zoom property, which is a property that is provided by yFiles, meaning that I'll get a zoom, different visualizations depending on the zoom, which is called level of detail rendering. So if you zoom in, you get to see more details, and if you zoom out, you get to see fewer details. I did the same with the movie node, where I also used the release date and even the number of votes. And the number of votes in this case is used to fill a rectangle full of stars so that you can see them like in a star rating. Let's see how that looks. Let's start the application. Let's turn that into light mode. When I zoom out, you see this is the low detail mode, where there's just the name and the icon. So you see the name of the movie and the icons. And if you zoom in closer at a certain breakpoint, you get to see the higher detailed node visualization with a smaller font. In this case, rather than just rendering the title of the movie, we also render the release date and the number of votes and the tagline. And for the actors, we're also rendering their birth date. Yeah, and now watch the cool effect with the icon. Once I zoom out, I get all the space to render the label, and once I zoom in, the label actually gets smaller, but on the screen it stays at about the same size. It's just that I have more screen pixels available when I zoom in, and then I get to see more details. So much about styling. Let's take a look at layout. Layout is the process of arranging the elements in a diagram. As you probably know, yFiles has many different layout algorithms available, so you can change the way your diagrams looks by focusing or highlighting certain aspects of the structure in your graph. Popular ones, of course, include the force directed. If there's no inherent structure in your graph, then you're probably going to use the force directed one. It's just trying to remove the overlaps, and that's it. Whereas the others try to highlight certain structures, for example, by connected components. There's different properties that you can have. What I would like to show you is the hierarchic layout, because this is one of the layouts that also allows you to constrain the diagram, the layout result, with data that you get from your database, or let's say from your nodes, because it doesn't have to come from the database, just like the release date that we had before. So what I'm doing here is I'm trying to use the grid settings. The grid settings allow me to partition my canvas into a virtual grid of several columns and rows. And with the column binding, I can determine what column a node should be placed in. There's some global properties that will affect the layout independently of the data, but this is something that is resolved against the node's context. So I am checking again whether this node has a label with movie. So, and if it is, then I know it has the release property, which is the decade over here. And if it's not a movie, I'm going to use 0. So this means that all nodes that aren't movies will be placed in the first 0-based indexed column, and all others are going to be placed in the column which corresponds to their decade, because this is truncated to an integer. And so I don't need to do the flooring. And empty columns are left out, basically. They are compressed to no space at all. So this will mean that, well, let's just see what happens. This will mean that we get to see all the actors in the first column, and then there's the movies that were released in the 1980s, and then in the 1990s, and then the 2000s. And this was just done by tweaking the layout, not by adding more elements or adding additional nodes or edges or visible information on the nodes, but by changing the layout, the way that we arrange the nodes on the screen or in the diagram. Next example is about using graph analytics in the view. As you know, Neo4j has some built-in analytics that you can run on the graph database, but you can also use yFiles to run graph analysis algorithms right on the client for the purpose of visualizing or for the purpose of improving the user experience, the user interactions, or changing the layout. So what do we have to do? I use the analytics node over here, and instead of directly outputting the graph to the layout node, I'll be piping it through the analytics node. This means that the graph will first get analyzed according to some algorithm, and then will be sent to the layout pipeline. The analytics node allows me to run various different algorithms like clustering or centrality algorithms or PageRank. And some of them have properties like do I want it to be directed or undirected, or I can even parameterize the algorithms, like telling what weights to use for the, in this case, what edge weights to use for the node between the centrality. And if I have some values in my data, I can use them to configure the edge weights. And if they're unspecified, I think they're just uniform weights. I can also filter certain types of nodes and edges if I don't want them to be part of the calculation. So if only a certain type of edges is relevant to my analysis, I can specify a filter binding over here. And most importantly, I can, where do I store those results? The result, in this case, I entered the property name result, so that the data will be stored with each of the, in case of the node betweenness, with each of the for each of the nodes as a value in their tag, meaning that I can use it in my template. So I changed for the purpose of this example, I changed the template. Let's take a look at it. So that over here I added another red rectangle with a certain constant height and location, but the width is dynamically being determined from the result value. In this case, it's 60 times the result. And once I do this, this means that when the algorithm runs, the graph analysis algorithm runs, it adds those values to the data, and the style renders these results as this in form of these, let's call it a small progress bar. Let's see, watch the progress bar change when I change the algorithm. So there's now the page rank of Cloud Atlas is obviously very high. I could also be using a label configuration and add it over here, so that this will be added as an additional label to my graph, to my diagram. Yeah, so much for analytics. The last thing I want to show you today is a simple kind of interaction. So far, this has all resulted in a pretty static application in the end. And you've seen that I made some arbitrary choices, for example, in my Cypher queries. So an obvious way to get an interactive extract, transform, and load pipeline is to parameterize the Cypher query. For example, instead of hard coding a limit of 30, I think that's what I had before, I'm now using a parameter variable in here called limit, and for the where clause, which reduces the results to those elements where the movie was released after a certain year, I'm using the year variable to constrain the query. And with this nifty parameter input, I can provide some JSON object that will be used for the query. And so this 3 nodes over here help me to define this JSON snippet and then parse this as actually some JSON value. So the limit is 30 and the year is 1999. And what I'm doing here is I'm allowing the year property to be specified via some binding, and the binding is specified via this value, to which I can conveniently connect this user input field. And this allows me to like enter a certain value over here. Let's try 2000. So this one produces the value 2000, and if I pipe this into this one, the year will be set to 2000. And if you watch closely, modifying the number will modify the results. So let's try the application. It first asks me for the user input, and then let's do 1990s or 1996, I don't know. And now we should only get to see movies released after 1996. So these are, yeah, obviously 1999. Yeah, that seems to have worked. Yeah, so that's simple user input. And this is how you create a custom graph visualization from your Neo4j database. Thank you for listening. Have a great day. Goodbye.